So today we're going to have a look at the POE document for network architecture. The module code is NWAR5122. So if you go to Rosebank College and go to current students, so Rosebank College, and then click on current students, it then takes you to your student timetables, applications, and student repository. Under student repository, I find my student material. So under student material, I'll click on IE student materials. And under the student materials, I'm just going to type in the search bar here, asterisk. Asterisk means it stands for anything. So that's shift and the number 8, NWAR, and then asterisk again, the star, and then I press enter, and then it will search for anything that has NWAR in the code. So you can see there's your module here, 5122, and you can see there's the document that we're looking for, NWAR 5122 POE. So if I open up the POE document, I can then go through the document here. Alternatively, I can download the document and store it in my OneDrive. So if I click on download, it opens it up in my Adobe Acrobat Reader. And from the Adobe Acrobat Reader now, I can go through the document and then I can save it in my OneDrive account. So I'll go File, Save As, and then I'll choose a different folder. I look for my OneDrive. So there's my OneDrive here, 2022, and then I'll select my folder called NWAR 5122, and then I'll save the document there. You can see I've already saved my document there. Alternatively, if it's not appearing on your student material, then you can go and look at in RC Learn. So in RC Learn, let me just open up a new RC Learn window. Under your module, you'll see under announcements, I put so under announcements, in your module, under course tools, announcements, there I put an announcement, POE document is available. So you can click on this link, and then it will take you to a shared folder in which you've got your module outline document, the POE document, and there's your how-to guide. Okay, so you can download it for either one of those two places. Now, looking at the POE document and what is required of us, you'll see that firstly, the instructions, referencing is important. You always make a backup copy of your POE or part 1, part 2. You store it in your OneDrive, so it's always available to you. And this is an individual POE, right? Then if we page through, we can see part 1 comprises of 100 marks, part 2 comprises of 60 marks, and the final POE is 50 marks. And if we weight them, the part 1 counts 25%, part 2 counts 30%, and your POE final submission counts 35% of your total mark. That gives you 90%, and then 10% is for your ICE activities. So you've been given your 2 ICE activities already. Again, it's under your announcements. So if I go under announcements, I can see there, I've got ICE task 1, which was activity 2.2.1. I needed to submit my OSI model there. And ICE activity 2 was to complete activity 3.2.1 from RC Learn. So if I go back to my POE document now, I'm going to scroll through and have a look at what is part 1 all about. So there's part 1. This task enables you to demonstrate your knowledge and understanding of computer networks. The task is divided into activities which relate to the learning units. You do not need to wait until all teaching is finished to start them. Some aspects of these activities will require you to do research. Real components that are currently available in the marketplace. So you need to research some real components that you can find online or in the marketplace. Furthermore, you will also be asked to make judgments about what is best for a particular scenario. Please note that there is not always one right answer. However, you will need to justify reasons for any choices that you make to get high marks. You are not required to design a complete network. So just for the case study, if you say you're going to do certain things, you need to say why. And in the case study, they would give us a story. You relate your answers to the story given to us in the case study. So activity one comprises of, part one comprises of 3 activities, activity 1, 2, and 3. Activity 1 counts 25 marks, activity 2 is 45, and activity 3 is 30 marks, giving us a total of 100 marks. Now let's have a look at activity 1, the scenario. JP Marketing is a marketing company that was established 5 years ago. The company has 10 employees, but has been growing steadily over the past 2 years. It wants to move to a larger premises and recruit more staff. It expects to have staff of between 15 and 20 within the next year. So they give us information because they want us to plan our network accordingly. So currently they have 10 people. They're going to move up to 20 people by the end of the year. Okay. Before starting the company, the owner studied computer networks, networks and computer systems. Just going to change my view. Okay. So before starting the company, the owner studied networks and computer systems at college. So he remembers some of the old technology. He takes responsibility for designing the office premises and purchasing equipment. So he's going to do the design and purchase of the equipment. In the past, he had some bad experiences with IT companies trying to sell him things that he did not require. So he's asked you to advise him. The owner is very keen to ensure that the network will be as future-proof as possible. In other words, he wants the network to still be operational even when technology changes. However, he also wants the network to not be expensive. So you need to be budget friendly, right? So if a 10,000 Rand computer can get the job done, you're not going to purchase a 20,000 Rand or suggest that a 20,000 Rand computer be purchased because it's unnecessary, okay? So be aware of the budget when you're doing your budget. The office premises that he wants to move the company into has a single floor of a modern steel-framed building. The office contains 5 rooms, 1 large open-plan office space, 4 smaller offices for managers. They're telling us this because when we draw a network diagram, okay, we need to show all of this on the network diagram. What does the office layout look like and which devices are placed where on that network? Then in the modern steel frame building, there are 3 floors of concrete construction and stud partition walls. They're telling us all of this so that we know Wi-Fi signals, it gets doesn't go through a concrete wall very well, okay? So if we need to extend or if we need to protect our network, it makes a difference if we have concrete walls. Stud partition walls means I can put cable inside them, okay? So it will be easy to run cables. And also it doesn't interfere with the Wi-Fi signal as much. Different companies occupy the other 2 floors of the building. So if I'm in one floor and other companies are in different floors, I need to be concerned about security as well. I don't want them connecting to my network or using my internet connection. The building is in a business park with high-speed fiber communications available. So it's telling me now, if I want to connect this network to the internet, I've got a fiber connection that I can use. Marketing in the 21st century is now dominated by digital marketing and media. JP Marketing is now dealing with an increasing amount of multimedia data and has subsequently employed a staff member with expertise in web analytics. Some staff will be using desktop PCs, others have laptops, and most staff have Samsung tablets. So it's telling me I've got PCs, laptops, and tablets. So this probably the tablets and the laptops are going to be using Wi-Fi, and the PCs or the desktops are going to use Ethernet. So let's have a look at the questions now. The owner remembers that at college, several networking technologies, including token ring, Ethernet, FTDI. He recalled that FTDI was the future, but cannot remember the specific details about it. As a result, he has asked you to complete the following. Question 1.1. Using suitable examples, briefly explain the difference between Ethernet, token ring, FTDI, and Wi-Fi. Now, these are hardware protocols. Remember in the example where I spoke about the OSI model, I asked you to draw an infographic with the OSI model, and also on that model indicate what was the function of each of the layers, what devices worked on each of the layers, and then finally, what were the protocols that worked on each of the layers. Now, Ethernet is in Learning Unit 3. We are currently on Learning Unit 3 now, okay, in our coursework on RC Learn. Learning Unit 3 speaks about network protocols and speaks about network standards. For network protocols, you need to learn the commonly used protocols like IP, SMTP, HTTP, DNS, DHCP. These are all common terms that we have come across, and they are instructions on how computers are going to communicate with each other at different levels of the OSI model. So Ethernet now works on the data link layer of the OSI model. How it works is it listens. All computers that are connected to an Ethernet network will listen to the wire. If there's no computer transmitting at a particular point in time, two computers can transmit, but if they transmit at the same time, there's going to be a collision on the network. And then they need to wait a random period of time and retransmit. So the problem that comes in with Ethernet is that if I have too many computers, I'll have too many collisions on the network, and it will slow the network down, causing network problems. So we can overcome that by using intelligent devices like an Ethernet switch that will reduce the collision domain. We can also do things like subnetting. So last time we learned about subnetting. We can break a large network into smaller networks so that it reduces the collision domain. Okay? So that's how Ethernet works. Now, the standard for Ethernet is called IEEE 802.3. The standard for token ring is called IEEE 802.5. For Wi-Fi, it is called IEEE 802.11. So these networking standards I mentioned to you in Learning Unit 3. Token ring works simply by a token being passed around the network. Whichever computer has the token can attach information. In other words, it can send information or it can receive information off the network. Can you see? So there's no collisions. They just simply pass a token around the network. And if I have the token, I can either send or receive information. So you must make a recommendation about which technology you should use. A good answer will relate your recommendation to the business requirements of JP Marketing, motivate your recommendations. So in your answer, if you are saying that he must use Ethernet and FDDI and Wi-Fi, you need to say when will he use each of them, right? So for example, the tablets are going to connect using Wi-Fi. The PCs are going to connect using Ethernet. How are we going to connect our network to the internet? We're going to use FDDI, which is the fiber network. Question 1.2, explain how Ethernet deals with two computers transmitting at the same time. You should also explain how modern Ethernets increase network performance. I've just explained that. CSMA CD, they collide, they wait a predetermined period of time, they retransmit the message if there's a collision. You need to explain then the use of switches, etc., to then increase the performance of your Ethernet network. Next activity, activity 2 from part 1. 2.1, draw a network diagram showing the main components of the network. Use MS Visio or other drawing tool. So like we have done last week, we drew a network diagram. In the same way, according to the case study, you are now going to draw a network diagram. So draw a network diagram according to the case study, all right? If they say you have an office, open plan office, you have 4 manager offices, you have wherever you're going to be putting your devices, you draw a floor plan, then you place the computers, the switch, the router, the wireless access point. If a server is required, you put a server, but this is a small network for now, 20 computers, right? So I'm not sure if we need a server for this. Generally, for smaller networks, we don't need a server. But you might determine, okay, if the network grows, we do need a server. So we might as well put in a server now. So you can decide. So that's the network diagram using Visio or any other drawing tool. Next one, invent a suitable MAC IP address and add them to the diagram. You should include the subnet mask. Remember last week we did a demo on the different IP addresses that we can use and subnet masks. So for the IP addresses and the subnet masks, what we need to do there is for at least 5 of the devices, we'll need to add IP addresses and subnet masks. We'll use the class C address range that I've given you, the private one, 192.168.10.1. You can go up to 100. 2.3, explain why you have chosen the particular components and why have you connected them in that way. Discuss the location of the components. Remember the components that we came across were things like switch to create a LAN. We came across router to do what? Connect my network to the internet. So you'll explain what are these network components that you have used: switch, router, network interface card, wireless access point, whatever you have decided, you'll explain where you placed it and why is it required. Question 2.4, give local prices and specifications of suitable hardware and software you recommend. So give realistic prices of hardware and software. Then the final question is activity 3. In activity 3, question 1 says, explain why devices on a network need addresses. We know that if a computer does not have an address, we cannot find that computer on the network. If you do not have an address, we cannot locate you. In the same way, to locate computers, we need an address. 3.2, explain the difference between a MAC address and an IP address. You should relate your answer to the OSI model. MAC address, we said, comes from where? Manufacturer. IP address comes from Yes, DHCP or static. I can type it in. Did we talk about what's the difference between MAC and IP addresses and OSI model? No, 3.2. So MAC is which layer? Data link layer. IP is which layer? Network layer. Okay, so you'll include that in your discussion on question 3.2. Then question 3.4, explain how a packet gets from one network to another. Your explanation should relate this movement to the IP address format. Remember, the IP address can be split into two sections, which was what? The network ID and the host ID. So you'll explain how, using the network ID, computers or packets get from one network to another network. The final question there is 3.5. As the internet has expanded, we have run out of IP addresses. Discuss using examples 2 ways how this problem has been solved. We have moved from IP version 4 to IP version 6. IP version 4 is a 32-bit address. IP version 6 is a 128-bit address. We can also use something called network address translation, where inside the network we use private IP addresses, outside of the network we use public IP addresses. So you need to decide here how the problem has been solved and then also give some examples. So that is part 1 of your POE explanation. You will go through the rest of the document. Next week, you can start working on part 2, which requires you to use your virtual computers. And we'll do a demo on part 2. So this is the part 1 demo. I'll also upload this demo that I've just done to the YouTube channel.